Hello everyone, welcome. Today I'll be talking about serverless IoT with Firebase. My name is Cleo and I'm a software developer by day and a hardware enthusiast by night. This led me to experiment on projects relating to Internet of Things, hardware, and electronics in general. So without further ado, let's dive in. So for this talk, I'll be introducing two characters. First is Firebase and next is IoT. So here are some pictures of real-world applications of Internet of Things. One is a smart home automation system wherein you can control things like your lights, your air conditioning, and also gather data from these devices. Another picture that you see is a smart gardening system wherein you can measure the temperature, humidity of the soil, and also like have some devices that would automatically water your plants at some certain times of the day, and also collect data about your garden for analytics purposes. And so with all of these things in mind, what really is Internet of Things? In a nutshell, Internet of Things means bringing internet connectivity to devices. So things means devices, connected devices and that collect data, and the data is stored in a database somewhere in the cloud for processing. And so what's really interesting about IoT is that when it's paired with other domain knowledge like data science and machine learning. So intelligent systems, aka smart systems, these are like technologically advanced machines that perceive and respond to the world around them. One example of that is the famous Google self-driving car. So how does IoT, data science, and machine learning come in play? So IoT, let's say we have a camera device that would actually capture the images of what an obstacle looks like. And then those images are sent to the cloud. They are processed through data science to gain some meaningful insights about them. And with machine learning, we can create a mental model of what an obstacle looks like. So when this self-driving car is on the road, it can quickly identify if it has an obstacle in its way, and after that, it can react accordingly. So these are really things that makes our IoT interesting. And so the second character that I'll be introducing is Firebase. So as we all know, Firebase is a Google technology. It is a backend as a service platform that allows you to create uh, um, applications that you don't really have to create from scratch. And so instead of creating uh, server applications in a traditional way, where you have a cloud instance and you have to code your backend, set up an API, and also set up the database. In Firebase, you don't have to do all of this. In Firebase, you just have to invoke certain functions and use some features and particular services that would allow you to store data and process them later on. And so serverless, it means serverless are event-driven cloud-based systems with a combination of third-party services, client-side logic, and cloud-hosted remote calls. So serverless actually would allow you to do more by abstracting all of these features that you have to build from scratch, and this is a perfect tool that would allow you to quickly prototype when you are building your IoT projects. And so in here, we will be storing our data using Firebase Real-Time DB, and we will be viewing the data that we have and interact with it through the Firebase console. And so here we will be showing an example of an IoT project. It is IoT in a very basic sense, wherein a hardware component would collect the data, and this hardware component is connected to the internet, and this data will be sent to a cloud server for later processing. So this is sending humidity and temperature data to Firebase real-time DB. And so this is the architecture. We have a DHT11 sensor that will gather the data that we will be sending. And we also have our development board, ESP8266 NodeMCU, that will interface with our sensor as well as with Firebase. So this is, by the way, a microcontroller. So our microcontroller, our development board is connected to the internet, and it will communicate with Firebase. And our data will be we can interact and view the data that we collected through the Firebase console. And so here is the schematic diagram of our hardware component. So as we all know, schematic diagrams are the blueprint of every electronic or hardware project. So in here we have our DHT11 sensor and our ESP8266 NodeMCU. So this black wire here is connected to the ground. This red wire here is connected to the power supply of 3 volts, whereas this input pin here is connected to pin D4. So we have to remember this because we will be later using this information to our code. And so let me show you a demo of how the IoT project works. So let me quickly pull that out. So in here, I have the project that I set up. So I have the DHT11 sensor and a NodeMCU, and I'm using an Arduino IDE to run my code. So this is written in Arduino C, and we have also the Firebase console. So in here, I have the data that I have collected previously because I also run this test, but I will be clearing that out just for us to see that we will really have a clean slate and see that we are getting data real time. So that's the part where I deleted the data that I have previously. And now we're waiting for our code to compile because it's actually like converting the human readable code to machine code that will be executed by our development board. So it's gonna take a considerable amount of time to compile that. After compiling, I have to reset my development board by clicking the RTS button. So right there. After resetting the development board, I will be opening my serial monitor where I can see the logs that I set in my code so that we'll know what is happening, and side by side with the Firebase console. So in here, we're starting to receive some sensor reading about the humidity and temperature, and that they are sent real time in Firebase. So I have here a hot water in a cup, and I will be putting the sensor near it just for us to have variations of the data that our sensor is giving us. And so in here, we're having temperature of 33, humidity of 43, and we're actually already seeing an increment in the values for the temperature. So from 33, it become 34 and 35. And so we can really validate here that our sensor is really working. And all of these data are actually sent real time from our development board to Firebase. And so as you can see here, we have our data there. And so let me switch back to my slides. So I'd like to demonstrate how the project come together. So aside from the hardware part, now I will discuss the software part. So where the magic happens. So we're actually needing 2 libraries in order for us to help interface with our development board to our sensor and Firebase. So in here, we have the Firebase Arduino. It is a library that we use in order to call built-in functions to call Firebase API from our development board. And also we have Arduino JSON because Arduino JSON is a JSON library for Arduino and embedded C++. Because in embedded systems, when you receive data from sensors or from other electrical components, it's usually in a in in a in a type that is not readable by, it's not human readable. So it's a series of characters that we cannot understand, and so we have to convert this data in order for us to make sense of the data that we are receiving. And so we're using Arduino JSON for that, to convert it to string and later on convert it into JSON so that we can send it to our cloud server and store it in a database. So in here, we have our module imports and variable declarations. The first block is we have the libraries that we're using. So in C, remember how you import libraries in C, stdio.h, conio.h, so we're also doing that here. So first is we are importing ESP8266 Wi-Fi for our network connectivity, Firebase Arduino for calling Firebase API from our development board, and DHT for our sensor. Second block of code actually is where our connection strings are. So for example, Firebase, for in here, Firebase host, that is the connection string to our Firebase project. Firebase auth is actually the database secret key. And of course, we also need to set up our Wi-Fi connectivity. So we have there an SSID and password, because we cannot send data if our development board is not connected to the internet. And lastly, for the last block, we have DHT pin there, D4. So remember, I told you that this yellow wire here is connected to our D4 pin in the development board. So we are setting that here. And we're also defining the type of sensor that we have, because we actually have two types of DHT sensor, DHT 11 and 22, but in here we're using 11. And finally, we are calling the DHT function, passing a parameter of the DHT pin number and the type of sensor. And so this is where the real magic is happening. So in here, we are instantiating the sensor readings, and we're also setting up an error handling here in case that we are not getting any values from our sensor, so that we just know what is happening and we can see that from the logs, the serial monitor logs. And in case that we are receiving data, we are doing some string manipulations here, converting the data that we have into a meaningful label. And finally, here we are calling Firebase API to actually send the data. So this is the format of the database that we will have. So we have DHT11 as a parent node, and next would be Humidity, and that is where the data will be appended right after. So we're sending the far humid and far temperature variables, which are actually declared in here. And so all in all, that is how the project came together. So what are the challenges and issues that you may face when you are developing your IoT projects? First is learning curve, because you're not just dealing with the software here, but also the hardware. So you have to know the architecture of the board that you are using. You also need to know how to use the components that you will be interfacing with your development board. You have to know the GPIO pins, which pin is for the ground, which pin is for the input pin, which pin is for the power supply, and all those things. So it's a best of both worlds. So you have to take hardware and software components into consideration. And another thing also is hardware failure. So many times I spend long hours of trying to debug my code, trying to assess where did I went wrong with my logic. And most of the time, not really most of the time, but sometimes the culprit is the hardware. Like my hardware is corrupted, my hardware is faulty, and it's not functioning already. So you have to keep in mind that when doing your IoT project, there are times that the hardware will fail you, not your code. And so the final thing is that having these development boards, having these electronic components and tools, these are actually like not these are pricey. So in my case, in my city, when I look at electronics shop, they usually sell components for appliances and computers, not really much on IoT development. And so what I do is I look online for shops, and most of these shops are located overseas. So when I have to buy them, I also have to ship them to my location, and that is one of the things that you have to consider. But despite all of these things, I really think that IoT is an interesting field. Knowing that you have an idea, and you can create these ideas and see them take form from scratch and have them used by people. I think that it's a very exciting thing. And and I think everyone should at least try to get to know, uh, try to explore this specific field in technology, as IoT is a big component for intelligent systems, and intelligent system, I think, is the future of technology. So before I end my talk, I'd like to leave this message that everyone can do it. Everyone can do IoT. You don't need to have a degree in electronics engineering to actually start building IoT projects. There's lots of resources online that you can use and get started with. There are lots of websites that you can refer to for inspiration on what to build, and that everyone can actually be a maker. So I hope that you soon start building your own projects and share them to the world. So thank you so much. I'm leaving the GitHub link there for the resources that you if you want to explore on what I did, then there's the GitHub link there. So daghang salamat. Thank you so much for listening and for for being with me in my talk. And once again, I'm Cleo, and if you have questions, then I'd be happy to answer them with the best of my ability. So thank you so much once again, and have a good day.